Hi guys. So keep solving the 31 Math GRE 93674. So 31 we give you a graph so that from 0 to 1 this is 1 minus x squared, and from 1 to 2 this is x minus 1. So this is x minus 1, and as you go to the area. So the answer is this is the 1 over 4 pi times half. Half is the triangular area. So the answer is C. So 34 R be a real number, and it gives you the 4 subset, and ask you about whether which one is a field. Okay, so basically this question tests you the general algebra common sense. So in order to prove this is field, because now we are in a subfield of ring, so basically subfield of R. So basically we need to test the closure and identity, and basically the most important is the inverse element. Okay, so first one, F1 is A divided by B, and B is odd. A, B, Z. Okay, so basically you can see the addition and the multiplication are close. Yeah, but one problem is that there's no inverse. For example, if 2 over 7 belong to F1, since 7 is odd, but 7 over 2 is the inverse and multiplication inverse element, but this 7 over 2 is not in F1, so F1 is not field. F2 is Z adjoint square root of 2. Then basically this is also not field, because 2 plus square root of 2 has inverse 2 minus square root of 2. But this is 4 times 2 plus square root of 2. And this is not in Z at the joint square root of 2. So 2 is not F2 is not a field. So F3, basically I don't want to explain. F3 is a Q square root of 2. And Q square root 2 can be viewed as a Q of polynomial x divided by x squared minus 2. So this is irreducible Pauli in Q of x. So irreducible polynomial in Q of x corresponding to the maximum ideal of Q of x. So x squared minus 2 is a maximum ideal. So Q of x quotient maximum ideal is a field. So this one is field. Okay, so up to now only F3 is correct. So from here we can already see the answer is F3. So the answer is B. But okay, so how about F4? People like to ask about F4. So F4, it looks like looks like Q at the joint the fourth root of root 2, but actually it is not, because the Q at the joint fourth square root of 2 should be A plus B fourth root this one, C fourth root 2 square, and D fourth root cube. So actually D is not a field. In order to prove this, you can check that. Can you find inverse of this one? So the inverse for this one should be this one, right? right? Should be this one, because these two times it should be this one. So these two times together will be 16 root 4. So it's 2, and 2 over 2 is 1. So, but the problem is this one cannot be written as b4 square root of 2, right? Because otherwise b will be, because if you multiply into this, you have 2b to the 4 equal to 8, and the b to the 4 equals to 8. Then b is not a rational number. So f4 is not a field. So fourth, then only f3 is a field. So we choose B. That's it.